Hi guys, this is the first video of week 3. Can you believe it? We're on week 3. And I know you guys already did the TED Ed lesson on Pascal's triangle, and we're just going to focus on binomial expansion on this lesson. So some of this thing should be quite familiar to you, so I'm not going to explain how Pascal's triangle work. I'm just going to focus on binomial expansions. Okay? All right. So then Pascal's triangle look like this. I think in the video it briefly explained how it's used for binomial expansion. So if you don't know what binomial expansion is, it's something that looks like this. So whenever you see something like a plus b square or cube or fourth power or fifth power, the power itself doesn't matter. It's the fact that there are two terms in that you are raising to a certain power. Okay, so famously this one I told you to memorize so that you don't have to FOIL all the time. It goes like this, and I mean if you FOIL over and over you can see this pattern, but this is also from the Pascal's triangle. So do you see how the power correspond with the number of row when we start the row to be 0, okay? And then the number that you see in the Pascal's triangle is the coefficient that goes with the binomial expansion. So what that means is that if we have a plus b cube, this will follow the third row, which goes 1a cube plus 3a square b plus 3a b square plus 1b cube. So the coefficients are 1, 3, 3, 1, just like we see in the Pascal's triangle. And you might be wondering, how did I come up with the power? It goes like this. So what you are not seeing in the first term is b to the 0 power, because b to the 0 power is 1. So essentially you're just seeing a cubed. So what happens is that the first term start with the highest power, which is the power that you're raising to, and then it loses a power each term you go. And the other term, the second term, it start with the 0 power, and then it adds power as you expand your expression. Okay, so that's the main idea of a binomial expansion. So let's look at then an example. So I'm giving you an example that's not a coefficient of 1. It has a coefficient of 2 already and 3 already. So let me write how this looks using the Pascal's triangle. So I know that the coefficient of the first term is 1. And it's the first term to the fifth power, and then second term to the 0 power. I know that 3y to the 0 power is totally unnecessary, but I'm just showing you how this works, okay? And then the second term uses the coefficient of 5, and the first term loses a power, whereas the second term gains the power. So when you add up the power of your x and y, it should always equal to 5, okay? And the third term is 10 now. 10, 2x cubed, 3y squared. And then again, 10, 2x squared, 3y cubed. And then 5, 2x, 1, and 3y to the fourth power. Let me write it underneath. Plus 1, 2x to the 0 power, 3y to the fifth power. I'm not going to show you the actual calculation because you have a calculator, but it's going to look like some number x to the fifth power plus some number x to the fourth y plus some number x cubed y squared, and then x squared y cubed, and then x and y to the fourth, and then y to the fifth power at the end. So this is when the two terms are added together. So what happens if they are subtracted? I think I have an example somewhere. Right here. Okay. So this is the case. Let me erase this so so that we have more space. I will show you how it works with the coefficient, and then you can kind of see the pattern, so you don't have to do it this way all the time. So the first thing is the coefficient 2x to the fourth power, okay, plus. So you always think of it as a plus if you're doing it this way. And then I think the third term is 4, 1, 4, 6, 4, 1. 4 times 2x cubed minus 3y to the 1 power plus 6 2x 2 minus 3y 2 plus 4 2x 1 minus 3y 3, and then lastly it's plus 1 times 3 minus 3y to the 4th power. Again, I will let you do the calculation on the calculator, but what I want you to notice is a sign. Do you see how it started with plus and then minus? And the reason it's minus is because the coefficient in front of y, it's considered negative 3. So basically, how I read this expression is this way. 2x plus negative 3 to the 4th power, okay? So then it becomes plus, minus, plus, minus, plus. Okay, so, and it'll be a little bit different if it's raised to the odd power, because it will end with the negative. But because this is an even power, you end with the positive, even though you have a minus 3y, okay? Because everything is raised to the even power, then your minus becomes positive. So what you can do then is that you can just worry about the coefficients and then put the signs later. So you always start with positive. So it's positive, negative, positive, negative, positive, negative. Okay? So that's one way to think about it. And there will be questions like these. Instead of asking you to expand the whole thing, they just want you to answer coefficient of a certain term that they are asking for. And you need to be thinking about this, because the first term is x to the 9 power, right? And then x8y is a second term, x7y2 is a third term, x6y3, and x5y4 and x4y5. So if you look at it, 1, 2, 3, 4, 5, 6. I'm looking for x to the 4th power times y to the 5th power. The coefficient of this thing is the 6th term, okay? So the easy way to think about this is, do you see how with the y, we don't start with 1, we start with 0. So you always have to subtract 1, and whatever the second term, think about it this way. If I'm looking for the 6th term, it's a lot easier for you to think about, okay, it's the second term, 6 minus 1 is what I'm looking for. Like y to the 5th power here. Does that make sense? I don't know if my explanation was good enough. I'm not so sure. So then, for the 9th term, obviously you can do the Pascal's triangle and figure out which one is the 6th number in that row. But unless you already have a written Pascal's triangle, this can be a little bit of work. So the mathematicians figure out that the Pascal's triangle and the coefficients that you get it is actually same as binomial theorem, which is the combination. So if you go to page 630, it shows you the formula for the binomial coefficient of a plus b to the n power, okay? And then it shows you the combination, which is NCR, n factorial, n minus r factorial, and r factorial. When r is this one. Okay, so it always works like this. It's the a n minus r br. So we are basing off from the power of the second term, not the first first letter, okay? So that's why I was explaining to you in terms of y, the power of y instead of power of x. So since I'm looking for the sixth term, r is not equal to 6. It's always 1 minus from that number you're looking for. So r is 5 in this question. So we're doing 9 because that's the power that we are raising to. And we're doing 5 because the power of y will be 5, not 6. Does that make sense now that I'm showing you the formula? So then it works like this. 9 factorial over 9 minus 5 factorial times 5 factorial. So obviously you could use a calculator, but for those of you who forgot about factorial, I just want to show you 9 factorial is 9 times 8 times 7 times 6 times 5 times all the way to 1, okay? So then the first one is 4 factorial, so 4 times 3 times 2 times 1. And then the other one is 5 times 4 times 3 times 2 times 1. So then you can see that this one cancels with the rest of it. And then I can kind of do something like this if I'm not using a calculator. So it's a 9 times 7 times 2, which is 63 times 2, which is 126. So I can just say my coefficient for the sixth term for this particular expression was 126. Okay? So then let's apply to this one. I'm just going to apply the formula right away because it's asking for third term. So that means I want 3 minus 1. So I'm looking for A11, B2. That's my third term because the first term is A13, second term is A12B, and the third term is A11B squared. And then if you remember, whenever there is a minus, it goes plus, minus, right? So the third term, plus, minus, plus, it's a plus. So my coefficient will be positive. So let's do this again. 13, 2. So it's a 13 factorial over 11 factorial because 13 minus 2, and then 2 factorial. So then everything gets canceled with 11 factorial. So the only thing I have left is 13 times 12 and then 2. 2 times 1, right? So it's 6. So 6 times 13 is my answer for the coefficient. Okay? All right. So now, this one, because this one is not giving you find the nth term, but it's actually showing you the term, you can just plug right into the formula. So I know that n is 8 and r is 5 because we always go for the second one. So it's 8 factorial over 3 factorial times 5 factorial. But this one is a little bit tricky because the coefficients of original expressions aren't ones, okay? So here, let me get this one first. 8 times 7 times 6 over 3 times 2 times 1. So it's 56. So 56 is my coefficient, but I'm not done yet. I need to do 2 to the 2 cubed and negative 3 to the 5th power. Because of these powers, do you see that you have to do 2x to the 2x to the 3 power and negative 3y to the 5th power? Then this, it's going to be a big number, will be the coefficient of that term. So does that make sense? So don't be just excited about the fact that you got the right coefficient. You need to make sure the coefficient of the original expression, and if it's not 1, you need to consider how to do the power. Last one. So this one is 11th term. And so we are looking for r equal 10, right? Because it's always one less. So it's C15, 10, which means 15 factorial over 5 factorial and 10 factorial, okay? So it's going to be 15, 14, 13, 12, and 11 over 5, 4, 3, 2, 1. I'm out of time, so I'm flying a little bit. Sorry. 7, 4, 4, 3. So whatever that number, so 7 times 13 times 3 times 11. We're not done because this one is different. It's a 2p to the 5 power. The reason it's 5 is because my r is 10. That means my first term gets 15 minus 10. And then it's 1 to the 10th power, right? And this will be the answer. I think I rushed a little bit at the end. I hope it was sufficient. Please email me if it didn't make sense. And the homework, I'll post it on Google Classroom.